In this video, we will see how to implement 2 by 1 mux multiplexer, and we will see how to implement 4 by 1 multiplexer by using 2 by 1 multiplexer, and after that we will see how to make test bench of 4 by 1 multiplexer so that you can verify your design. So let's get started. Here I have just written one mux, which is actually the module name, and in this mux we have three inputs and one output, and S0 is actually the input, which is selection line. Now after, you will see here one output is actually Z0, and we have seen here I have written this equation, which is actually the assign Z0 to this whole value. This actually means that if you know the multiplexer equation, a 2 by 1 multiplexer equation, so you can easily write it down, this equation. There are a lot of other methods to implement the multiplexer, but I think so the equation which is actually helping me to do in this way, because it's very simple. Now and now after that we have this AND module, because this is actually a very simple code for 2 by 1 multiplexer. And after, if you know, I have right here module, and module is actually the module 4 by 1 mux. This is actually the 4 by I have written the code for 4 by 1 multiplexer. So here Z is actually again the output, and I and S are the inputs, and S is actually the selection lines. In this case we have two. Now if you know the inputs, we have four inputs because it's a 4 by 1 mux, so that we have four inputs, which is 3 down to 0, such as you can say that I0, I1, I2 and I3. And here inputs as well is actually the selection line is actually the input as well, which is S1 and S0, and Z is actually the output. If you know, here I have written X and Y, which is representing the wire. Why I have right here X and Y, let me just show you. So uh, if you know the multiplexer 2 by 1 mux, so here you can see, here we have, let's say we have, this is actually I 1 mux, and then here we have 1 mux again, and is actually, this is, if this is actually X and if this is Y, then this inputs will go to the next multiplexer, and then this is actually our Z output. So these are the inputs I0, I1, I2 and I3, and X and Y are the outputs of these two multiplexers. Now if you see here, these are the actually internal connections. So we are for the internal connection in system Verilog, we always use wire. So by just by representing the internal connections. Now I have just instantiated the module which I have made above, and by using instantiation I have just written the module name like mux1. You can just uh, make your own name, whatever you want. And then X, which is our output. In this case, if you will see here, X is actually the output. After writing the output, we have one I0 and I1, they both are the inputs, and then we have written S0, which is actually the selection line in this case. So this is actually the selection line, we can say, which is, I am writing here, which is S0. All right. This is the selection line. I have again instantiated the same module by just giving the name mux2, and in this case we have y output, and I2 and I3 are the inputs in this mux you can see here, and y is actually our output in this case, here you can see. And after instantiation we have again instantiated the last module of our 4 by 1 mux. So 4 by 1 mux, here you can see in this case we have z is actually the output, or in this case 4 by 1 mux output, and the two inputs are x and y. These are the inputs for this mux. So this is one input and this is another input. So these two inputs, and then we have selection line, which I can say it's a is in this case we can say is a S1. All right. After writing here, then we have this and this module. Now this is these are the two, this is 2 by 1 mux and this is 4 by 1 multiplexer code. Now I have right here test bench for 4 by 1 multiplexer. So I have decided to take as a register as an input, and selection line and output, they all are registers. And then we have initiate the values. So initial, begin, and then I have write all the possible inputs for this multiplex 4 by 1 multiplexer. So the we are not concerning about I not I1 I2 I3. We are just concerning about the right for the 0 0 values. For if the S0 and S1 is zeros, then we should need to get the values of I naught. So the if S naught and I naught both are zeros, then we will get the I naught output according to the multiplexer rule. So here, if we have selection line, this is actually 0, and then this is 0, then we will get I naught as the output. So the output value will be I naught. So if you will see in this code, I have just 3 times I have written the same selection line, uh, which is representing two binary 2 bits number, binary 2-bit number, and here the both are zeros, and here we have again zeros, and then I have 3 times I have written 0 1 0 1 0 1, and 3 times 1 0 1 0 1 0, and after and again 3 times 1 1 1 1 1 1 1, which is if the selection line is 1 S0 and S1 values are both are 1, then we will get the I4 I3 at the output. uh, Here this will be the output if both are 1. If this is 1, this is 0, then we will get I3. If this is 1, this is 0, then we will get I2. All right. So now we will just run this test, this whole code, and then we will see the values of the output and waveform of the output. Now our simulation reached up to 79%. As the compilation will complete, then I will show you all the waveforms that we need to see for the verification. Now you should now our compilation is successfully done, and then we will use the RTL simulation so that we can verify the our logic that we have built for 4 by 1 multiplexer. Now I have opened model sim, and we will see the all the waves that we have required for verification. Now come here and then simulate all this test bench values. So now it is coming here, and then as it will open, and then we have need to add wave. All these waves are here, and then here you can see the input values I0, I1, I2, and I3. These are the selection line. Here we have one. Z is actually the output. Now after running the uh, first stimulus, you will see here the values. Now you can see here we have the value of Z is actually 1. uh, Here you can see you. Now after again, if you will see here the if you will see the I naught and I1, sorry, S naught and S1, both are zeros, then here you can see the output follow the value of I naught. And then same for this case, if the value of I naught is 0, then output is 0. And here you can see the both selection lines are 0. Now I am running again one stimulus. So here you will see if if the S naught value. So if here you can see the S1 is 0 and S naught is 1. So in this case, if this is value, then you can see here the output follow the I1 value. Here you can see the Z is actually follow the I1 value. And if you will see here again, the I1 value is again the Z is following the I1 values. Now I'm running it again, and here in this case you will see again the I1 value is coming to the output. Now if this is the selection line is 1 and 0, then the I2 will be the output. So I2 is actually value is 0, and here you can see the 0 values. Again, if you will run it again, and then here you can see the I2 is 0, the output is 0. And here in the last case, if the I2 is 1, then you can see here the output is again 1. You can also verify from this or from these waves, so they are fine. But it's all up to you. To I think it's an easy way to see here rather than this which values are high or which value is no low. But if you will see the selection line, according to the selection line, you should know which inputs will come to the output. So it will be easy rather than just saying these all waves. Both are the if you have any problem, you can just see here, and then you can verify your design. It's all up to you. But now here both are one, so if you know the selection, then I3 will be the output from our theory. Now if you know, here we have 1 1, and then you will see here the output follow the I3 value, which is 1. And now again, if you will just simulate it, and then here you can see the output again follows the value of I3. Alright, so this is the test bench. So if you have any question, any query, you can ask me. And if you are seeing any problem here, or you are not able to understand anything, you can comment below, so I will help you as soon as possible. Thank you very much.